Welcome to I Put a Brain in It. Today I want to talk to you about software agents. I want to explain a little bit about how software agents differ from computer programs. And I'd also like to show you how to build the simplest software agent using a large language model like ChatGPT or Google Bard. So what is a software agent? In everyday English, an agent is someone or something that's trying to do something on our behalf to achieve a particular effect. So, for example, a estate agent is trying to sell you a house, a talent agent is trying to find an actor a new role. So, a software agent is a piece of software that's trying to do something on our behalf to achieve a particular outcome. Now, there are many academic ways to define what a software agent is, but for today, I just want to focus on two particular aspects: planning and goals. A program such as Excel or Instagram, they don't have goals. They're not trying to think about how they're trying to download pictures better or retouch photos better or calculate your taxes better. There's also no planning. You can't expect Microsoft Excel to start thinking it's found a better way to calculate your taxes or submit them on your behalf. It's just running the calculations that it's been hard coded to have. So something that does have goals is something like a bot. An example of this might be a bot that auctions on your behalf on eBay. It has a goal of trying to achieve the best price, and it knows when it's completed its job by the auction being finished. But it has a fixed execution strategy. That auction bot isn't suddenly going to start thinking, hold on, I can get a much better price if I take out all of the other auctioneers, for example. Instead, it's just running its hard-coded plan to get the best price to achieve its goal of winning the auction. Something like an agent is something that does have goals, but it's a bit more flexible in how it executes its plan. So a great example of an agent would be Waymo, the self-driving car. It has the goal of getting you to its destination, but in terms of its execution strategy, it could choose any number of routes to get there. Now, it doesn't have an unlimited set of execution strategies. A Waymo car is not suddenly going to think, well, it's actually easier to get you to your destination by calling you a taxi. No, it's going to drive you there. So an agent is something that's working towards a goal and it's got a set number of actions that it can execute, but the order of those actions might be different depending on what its goal is. But something that's more sophisticated is an intelligent agent. This is something that could generate its own goals and also has a novel execution strategy. A great example of an intelligent agent, is humans. Yeah, we generate our own goals, and we might have any number of ways in order to achieve them. Like that self-driving car, for example, if it was an intelligent agent, may decide to stay parked up in the garage and call you another self-driving car to get you there. So today, we're going to try and build the simplest agent we can. Something that has goals, but it doesn't have a hard-coded execution strategy. Here's what we want our agent to control. I've built a simple kettle simulator that's pretty smart. It can be connected to over the internet and receive commands to heat, to turn off, and also can return its status. But it's also pretty dumb. This kettle doesn't know when to stop boiling. So we're going to build an agent to be able to control the kettle, to start it boiling, and know when to turn it off. What we'd like to do is first run a mock in ChatGPT to see whether a large language model is even capable of returning the types of commands that we expect to be able to control our kettle simulation. Let's tell ChatGPT what it's doing. You're an agent controlling boiling a kettle. Try to boil the kettle as efficiently as possible. The commands to control the kettle are on, start heating, off, stop heating, status, get the temperature, and then sleep. So This is probably one of the most important commands to turn this into an agent. If the large language model feels that it doesn't need to do anything for a little while, what we want it to do is to say, okay, I don't need to do anything. Could you call me back and I will do something after a certain amount of seconds? So the agent is giving up control, its agency for a little while. Then after a certain number of seconds, we wake it up and say, hey, X number of seconds have passed. What would you like to do? So ask to be woken up after n seconds to be asked for a new command. Let's write another important command, quit. Tell us when you have completed the goal. What is your next command? On. Okay, so our large language model hasn't even asked the status. Let's pretend we're the kettle and say that we're heating. Okay, wants to sleep for 30 seconds. We're going to pretend it's 30 seconds later. Let's go t plus 30. What is your next command? Status. Okay, that's good. Our large language model wants to know what the heating status of the kettle is. So let's pretend that we are heating and the temperature is now 30 degrees and the time is t plus 30. Okay, it's going to sleep for another 30 seconds. What is your next command? Status, of course. So again, we're pretending that we're the kettle, providing the status. So heating is on, temperature is now, let's say 98 degrees C. We're very close. And the time is t plus 75. Off. Okay, so the large language model is now decided that it's completed its job. So what this shows is that a large language model can be used to be given a goal of heating a kettle, can be given some actions, and those actions can be turned into a plan by the large language model constantly looking at the status and saying, okay, this is the command that I'd like to execute next to achieve its goal of boiling this kettle. So we know the large language model works. The next stage is to try and build a piece of Python code that acts as the agent. Here's what we're going to try and build. Our agent over here comprises our large language model plus a piece of Python code, and our simulation is the kettle that we've already shown that's written inside a game engine called Godot. So what's going to happen is there's going to be an initial prompt that gets sent from the Python code to the large language model. That'll be to heat the kettle. And the large language model will say, okay, this is the command that I'd like to call, because part of this initial prompt will include the commands that the agent can call. If it's a command such as sleep or quit, the agent can handle it. But for any commands that the agent doesn't know how to handle, such as heat, standby, or status, it'll pass them on to the kettle. The result of that command, so standby will say that the heating is off, status will return the temperature, that'll be given to the agent piece of Python, which will then say, hey, this is the result of that function call, large language model, what would you like to do next? So we have this loop going round and round until eventually the large language model says, quit, I've achieved my goal. So let's go look at what that agent code looks like. Here we have our Python agent code, and it's pretty simple. While true, give a command to GTP API and give that code to the kettle. If we go look at the GTP API, we have our initial prompt, you're an agent, and then we have trying to boil the kettle as efficiently as possible. So this is what we saw when we were running the manual experiment. But here's where we tell the GTP API of those different functions on the kettle that it can call. The exact same as we wrote it out in English, this is just a much more structured way of telling ChatGPT what functions it can call. So we have heat, we have standby, status, we have sleep, and we also tell it that it can take a number of seconds to sleep, and we have our quit function. So every single tool is also given a description, and that tells the GTP API of exactly what the function does. What this class is doing is it's holding a list of all the messages that have been sent and received from the GTP API. So down here, if there are no messages yet, we know it's the initial prompt, and if there are messages already that have been stored, we know it's probably a function call. This is where we call the GTP API with all of our messages so far, and then we get the first message response back from GTP, and we try and take it apart. If the message says, hey, call a function, we try and package it up and send it out. That was the class that deals with GTP API. So let's look at our command executor. We've actually got two different command executors. One of them is our special agent command executor. This is taking the tool call from the GTP API. If the command is quit, we quit our agent. If the command is sleep, then we sleep the thread for the number of seconds, and then we call back to the GTP API and say, hey, the current runtime of the agent is this. What's your next command? If the command is not quit or sleep, then we delegate to the kettle. This has been created with a command executor that all delegated commands will be given to, and that's this WebSocket command executor. Very simple. So it connects to the kettle via a WebSocket. It's given a command, and all it's doing is sending that text to the kettle. So let's go look at the kettle code and see what it's doing. The kettle simulator code is also pretty simple. There's basically two script files in Godot. We have this WebSocket controller, which provides a WebSocket server, which the agent connects to, and any command that comes in gets sent to the temperature controller behavior. In the temperature controller, we have three explicit methods that get called via reflection. So you can see status, heat and standby. There are on-off commands, and that really is it. Here we have our kettle simulation, and here we have our agent ready to run. So let's run it. And the first thing it's going to do is call ChatGPT with the prompt boil the kettle, and it's already said to start heating, and then it's asked for the status. We've provided the status from the kettle of what the temperature is, and it's heating. See, it's already heating, and then it's decided to sleep for 10 seconds. Then it's asked for the status again, and it's decided to sleep for another 20 seconds. So in 20 seconds time, the agent will wake up and then say to the GTP API, hey, what should I do next? Here we go. It's decided to, what we got? Decided to ask the status. Okay, starting to boil a little bit. It's sleeping for another 10 seconds. And it's decided to wake up, and it's asking to get the status again. It's started to sleep for 5 seconds. It's boiling away our kettle, and it's getting the status 106. It decided to stand by, and we see it's gone into a standby state, and then it's decided to finally quit. So our agent boiled the kettle. There you have it. We've managed to build a very simple software agent that works towards the goal of boiling our kettle. Now, there's no planning in this agent, but at the same time, there's no hard-coded logic either. It's trying to achieve its goals from a simple set of actions, and the large language model is helping us choose out those actions which are the best ones to achieve the goal. It's a very simple design, but it's something that we can elaborate further to build more complicated behaviors. The code is in the description below, and if you learned something from this video, send me a like, and that's it. Bye for now.